Good. Welcome everyone to this webinar on energy transition minerals and e-mobility organized jointly by the University of Eastern Finland and the United Nations Economic Commission for Europe. I'm Diana Velázquez Ruiz from the University of Eastern Finland, and I'm going to be one of your hosts today. I would like to thank you all for being here today, and we welcome and thank our speakers, some of whom are joining us very early in the morning in their time zones. We are excited to co-host this event with the UNECE and would like to thank them for their contributions to designing and convening the event. Today, we're going to hear about ways that we can minimize the demand for energy transition minerals for e-mobility. And we have some interesting examples from research and from practice as well. So in recent decades, improvements in battery and renewable energy technology have placed the combination of e-mobility and renewable energy as one of the solutions to reduce greenhouse gas emissions from mobility. E-mobility can also deliver improvements in air quality and noise levels, resulting in health and quality of life benefits in urban areas. In parallel, as the UN Secretary General Antonio Guterres has stated, a world powered by renewables is a world hungry for critical minerals. So the growth of e-mobility also comes with a significant increase in demand for energy transition minerals, which are those minerals that are necessary for energy transition technologies and that are often included in critical minerals lists. Think, for example, lithium or graphite for batteries, or aluminum, copper, or steel for vehicles and networks. We have long known that resource extraction or processing are not without impacts, and that those impacts are not distributed evenly. They're distributed unequally in what is already a very unequal world. The International Resources Panel, a scientific panel established by the United Nations Environment Program, issues each year its Global Resources Outlook. And in their 2024 edition, they show that the global patterns of resource use and consumption have continued to intensify and to accelerate. The report concluded that without concerted global action to reduce resource use, the world faces increasing damage and risk amid a triple planetary crisis. So their call is to find solutions now towards global sustainable resource production and consumption. At the University of Eastern Finland, our motivation to co-organize this event is the Summit Project, which is an exploration of energy transition, mineral, and urban e-mobility nexus from the perspective of the people who shape the future of urban e-mobility. I am interviewing practitioners from different disciplines and in 3 different cities, people who work in strategy, people who work in mobility, who work in transport. And the aim is to get a sense of how they understand the nexus between energy transition minerals and e-mobility. In those interviews, we've seen like 2 entry points to have conversations about energy transition minerals in the context of mobility electrification. One is the procurement angle, where human rights issues in the value chains are very well recognized by several of the practitioners. The other angle is more the demand side measures. So what can be done to reduce the magnitude of the demand for minerals, so to reduce car use, to have more public transport, to reuse batteries, recycle them, recover the materials, and keep them in circulation for as long as possible. Procurement is really a very large field, so we're going to plan to do another webinar about the upstream issues in the value chains of e-mobility and how they're trying to be addressed through procurement. So we're going to keep that for another time. I'm going to share the webpage of the Summit Project, and you can keep informed about that future seminar. But today, our focus is on demand-side measures, so measures that can reduce energy transition mineral demand. For example, better public transport, measures to reduce traffic, and disincentivize private car use, and ways to use more secondary materials to minimize virgin material demand. We bring you two research examples about solutions to minimize the virgin material demand that results from mobility electrification. Mr. Emmett Hopkins from the Climate and Community Institute and Professor Fan from Brunel University of London are going to present them. And we're also delighted that Kjersti Koffel from the city of Oslo is going to offer commentary from her perspective as a practitioner in Oslo to kind of bring the theory to practice, and mostly in response to Emmett's presentation. After that, we're going to have Professor Rauno Sairinen, who's also from the University of Eastern Finland, facilitate the Q&A, and we'll do some final comments. But for now, I would like to introduce you to Ms. Nadezhda Hamrakulova, who is Economic Affairs Officer in the Sustainable Energy Division of the UNECE and a co-host of today's event. Over to you, Nadezhda.
Thank you very much, Diana. Can you confirm that you hear and see me, as I had some issues to connect? Thank you very much. I would like to extend my warm welcome to all the participants of this event on behalf of the United Nations Economic Commission for Europe. It's a real pleasure for us to co-host this webinar with the University of Eastern Finland, and we also hope to continue collaboration with this university, also with colleagues from other universities, to explore how the energy transition can be more sustainable and also more fair. As Diana actually underlined, the shift to e-mobility can offer to people also enormous benefits, but it also provides certain pressures on the minerals and the materials that can underpin batteries, vehicles, and charging infrastructure. So meeting these challenges require us to think not only where the resources come from, but also how much we really need the resources and how responsibly we manage them, and how more responsibly we can manage them actually than currently now. So this is why the frameworks that we developed at UNECE, such as the United Nations Framework Classification for Resources and the United Nations Resource Management System, actually make a difference in this. UNFC, the United Nations Framework Classification, provides the language, the common language for classifying the primarily mineral deposits and the secondary resources, such as the recycled materials. We will hear about this also today more. By putting on them or the resources on the same footing, and by this classification, UNFC helps the government, the cities, also companies, to see the full spectrum of possible options to meet the demand. So that will be with less the primary extraction and with more circular flows. The second tool that I mentioned, the United Nations Resource Management System, actually goes a bit further. It sets the principle for the resource management that are aligned with the Sustainable Development Goals, and that looks in principles such as transparency and looking at just transition, and also circularity and community benefits, and etc. So for the electric mobility, this tool helps the decision makers align the mineral supply, infrastructure development also, and further planning for mobility in way so that it can reduce overall demand and then also maximize public value. At UNECE, we also established the let's say, community of experts, the task force on electric mobility, which supports the member states and other partners in advancing policies, standards, best practices to the sustainable electric mobility systems. So it provides overall the platform to connect resource management approaches, which I mentioned earlier, such as UNFC, UNRMS, with also practical solutions that are being introduced or looked for cities and industries. So in this context, this seminar actually reminds us that demand-side solution, like reducing the private car dependence, or promoting shared or public electric mobility, right-sizing batteries, all of extending the life approaches and the life cycle is not only the transport issues. We're also looking from the resource management perspective and the strategies that lighten the burden on the communities and the planet in whole. So that's with all this, I would like to just highlight that this brings us also to the possibilities to bridge the high-level principles with the real practice that's happening on the ground within the cities, within communities. And we hope with this seminar, we will also start looking into these insights, and today's researchers and also practitioners' point of view will provide us more information on this, and we will start the discussion on how we can apply those approaches to accelerate to a more sustainable electric mobility transition. I think I will stop at this point, and I will give back the floor to Diana. Diana, sorry. Thank you.
Thank you, Nadezhda, for putting the seminar in context within the, the work of the UNECE, which is very important work. So now we'd like to welcome Emmett Hopkins, who is from the Climate and Community Institute. And again, I want to thank Emmett for getting up very early to be here with us and share a report that really was one of the inspirations for the summit project that we were doing at the University of Eastern Finland. So Emmett, you're welcome to start sharing your slides as I present you. Emmett is Policy Manager, Transportation and Mining at the Climate and Community Institute. He works with the Climate and Community Institute and its partners to advance a new vision for mobility that centers justice across the transportation supply chain. He previously worked as Operations Director at Climate Mobilization Project, focusing on transportation justice. So Emmett, the floor is yours. Emmett is going to present on zero emissions transport with more mobility and less mining. You have 15 minutes, Emmett, and when there's 3 minutes left, I'll appear on screen. I'll give you a note to let you know. Please go ahead.
Okay. Thank you so much, Diana, and thank you everyone for the chance to speak with you today. I'm going to share some research that explores how we can decarbonize quickly while increasing mobility and decreasing the amount of mining needed for transition minerals. First, just a quick background on Climate and Community Institute. We are a progressive climate and economy think tank. We work closely with on-the-ground campaigns to pass new policy, improve implementation, shift narratives, and deepen coalitions. And we are based in the United States. We have a network of over 60 research fellows who are spread across a variety of topics. And today the topic we will be talking about is transportation. I want to start by just sharing a few quick background pieces of information to make sure that everyone is starting at the same baseline and to help people understand the narrative that our research team was confronting when they started this project that I will describe back in 2023. So we know that any path to zero carbon must go through the transportation sector. We know that globally, the sector accounts for a large percentage of emissions, and this is even more true in the United States. And most of these emissions come from private automobiles, 58% in the US. We also know that there are some challenges with hinging our entire decarbonization strategy on simply electrifying every vehicle in the current transportation system. It would require a massive amount of electricity, potentially up to half of the electricity produced by the United States. It would require replacing vehicles at a much higher than normal rate, and it would take a large amount of resources, in particular, the extraction of minerals for batteries. And so speaking of batteries, lithium is a mineral currently used in most commercially viable EV batteries for a variety of reasons. And as a result, we see that demand for lithium is rising dramatically along with new mining projects. But this mining, of course, comes with harmful impacts on water resources, on ecosystems, and human communities. And so we're currently at risk of replacing the oil and gas extraction industry with a battery mineral extraction industry with all of its own harmful impacts. So back in 2023, our research team could see this building tension that put climate advocates and mining justice advocates on seemingly opposite sides of the argument. And the research team asked this question: is there a pathway to reach zero emissions and minimize mining at the same time? So it's common to see the mineral demand curves like this one here, which show future demand for lithium, in this case shown in these colored bars at the bottom, and they predict future lithium supply, in this case shown with this red line. And these demand curves are really driving a gold rush mentality with respect to global lithium exploration. The anticipation of a huge market for minerals gives the green light to investors and mining companies. But our research team wanted to say, wait, hold on a minute. These demand and supply curves are not a foregone conclusion. They really are policy choices. And so, as one example of this, we can consider the amount of lithium required to move a single person using different types of vehicles. It varies enormously, as we can see. The electric Hummer would require 4.8 kilograms per person, for example, whereas the electric bus, only a tenth of this. So our choices as a society for how we move around will greatly impact the quantity of minerals we need to dig from the earth. So we have different policy levers, such as this, that we can theoretically pull to change how many minerals are needed. And our research team set out to test the impacts of different policy choices through a model with inputs and outputs. And so I'm now going to walk through the basic inputs or variables for that model, which can also be described as the policy levers that could be pulled to influence mineral demand. So the first input would be a transportation scenario, which dictates the rate of car ownership in the future. You don't need to read all the details here, but basically the summary is that scenario one represents the status quo in the United States with high levels of car ownership. Scenario two assumes lower levels of car ownership in US cities, comparable to those seen in European Union cities. And scenarios three and four further decrease car ownership through improved public transit and higher density urban land development. And these transportation scenarios represent one variable that could be manipulated within this model. And now I'm going to explain the other variables. So this graphic here shows the top row represents these transportation scenarios that we just looked at. The second row explains the second variable, which was battery size. So the medium battery size here represents current battery sizes, average battery sizes, while the smaller batteries is a scenario that could be possible with smaller average vehicles and a more extensive charging network that could reduce range anxiety. And then we also considered a scenario with larger batteries as a continuation of the trend that we're seeing towards large electric trucks and Hummers in the United States. The third row represents the third input considered, which was the length of EV warranties and whether this might influence the time a new battery stayed in circulation. And then the fourth input was battery recycling, which in this case was treated as a simple on or off switch in the model. And this model was designed to forecast lithium demand in the United States specifically under these different scenarios. So what were the top line results from the model? When we compared the worst case scenario with the best case scenario out to the year 2050, we could anticipate a 92% reduction in lithium demand. And if we took a more moderate change and compared the status quo with a simple reduction in vehicle ownership, in other words, just changing one of those inputs that we looked at, we could expect a 67% reduction in lithium demand out to 2050 still. So clearly, the lithium demand curves that are being published are far from set in stone. They come with a set of assumptions and can be influenced through policy. It's also possible with the model to isolate certain variables and evaluate their potential as independent policy levers. So if we isolate just the transportation scenarios by themselves or reducing car ownership without the other changes, we could reduce lithium demand by 18%, 41%, or 66%, depending on the scenario. We could reduce battery sizes from medium to small, and by itself, that could lead to a 28% reduction. Conversely, if we increase battery size from the current sort of medium average size to larger sizes, by that self, that could lead to a 56% increase in demand. And then recycling by itself could shrink demand by 40 to 54%. And so what we can see here is that any given one of these policy choices and these changes in variables would have a substantial impact on the amount of lithium demand. So overall, the model suggests that the pathway to decarbonize quickly while minimizing mining impacts goes through three main changes. One, reducing car ownership through increasing public transit and developing high-density urban spaces. Two, maintaining or better yet, reducing battery sizes. And this could be through vehicle design and battery charging networks and battery chemistries. And third, implementing strong battery recycling, perhaps through industrial policy and vehicle and battery standards that require batteries to be easily removed and repurposed or recycled. And the model found that changing warranty periods had little impact on lithium demand in the case of this research. And then we would also expect a number of other co-benefits of these types of policies, kind of further giving us reason to pursue this type of an approach. Now, the impact of this research in the United States has been somewhat of a shift in the mainstream narrative. This study got quite a bit of press and circulated widely among mining, climate, and transportation organizations. And the visibility can be seen in talking points and similar research projects being published across various organizations in the 2 years since this project was published. And so we're really seeing these types of mineral demand reduction interventions discussed more in mainstream climate policy discussions now, where before we were seeing electrification advocates and mining justice advocates consistently butting heads, seemingly at an impasse. Now, to a greater degree, we're seeing that they're able to speak within this kind of unifying framework that allows electrification advocates, mining justice organizers, and even transit advocates to all push in the same direction and use a framework that addresses each of their goals and concerns through a concept of electrifying effectively and quickly, but taking steps to minimize new mining and increase mobility. So with my remaining couple minutes, I'd like to share with you briefly a couple related projects. One is a follow-up project that took this idea of different decarbonization strategies that move towards more mobility and less mining. And we applied investment scenarios to these decarbonization strategies and asked how many new jobs would be created under each scenario. And just the top line finding from this was that under the most ambitious investment that focused on demand reduction strategies of diversified transportation and circular economy, would create a net total of 1.8 million direct new annual jobs. This is in the US only by 2035. And meanwhile, the status quo scenario, focusing just on kind of the current policy of converting more cars to electric vehicles, would only create about 10% as many jobs. So we can also promote the pathway of decarbonizing with more mobility and less mining as one that's good for the economy. So we can add this to that list of co-benefits that I just put on the screen earlier. And I invite you to explore more about this research on our website, where we have the more detailed results such as these, as well as details about specific sectors. Like here, I've shown an example of the construction sector. We also look at manufacturing and consider jobs creation in each of those sectors. And finally, I just want to leave you with the idea of supply chain solidarity as one way that we are exploring to make progress towards decarbonization with more mobility and less mining. We've been bringing together people who work or organize across different nodes of the transportation system with the hope that greater connection and understanding can lead to more people pushing in the same direction, finding shared goals, and building greater power ultimately. And so in one example of this that we see here, we brought a delegation of people from across the supply chain to the state of Nevada to see firsthand the impacts of lithium mining on local communities at ground zero of lithium exploration in the US. And you can see here that this group represented a wide spectrum of the transportation system or supply chain. So we had people working in mining justice organizing. We had people from battery production and recycling fields. We had people working on the shop floors at auto factories on electric vehicles, and we had transit workers, and transit riders, as well as Amazon delivery drivers, organizing with Teamsters. And so this cohort who met in Nevada actually continues to meet, is developing a set of shared principles of solidarity and exploring how to support one another's campaign goals. And so the idea is something like this. We have indigenous communities fighting against a lithium mine in Nevada where General Motors, the auto company, is the primary investor, and where General Motors will be purchasing 100% of the lithium. And when these indigenous organizers team up with auto workers who also work at a GM factory in Detroit where the lithium is going to be used to build electric Hummers, when these people team up and can push in the same direction, then their voices can be stronger and they can hold more leverage to win concessions from companies and policymakers. So that's part of the vision. And again, thank you for your time in sharing this with you. And I'll hand it back to you, Diana.
Thank you so much, Emmett, for such a great presentation, and you covered different important pieces of work. I really like this other report about the employment, analyzing the employment consequences as well. So by all means, put the link to those if it wasn't visible in the slides. Feel free to put it there. So as I was saying before in the chat, we're going to give the floor to our speakers one after the other, have all the presentations in sequence, and then we'll open the floor for questions. But you can, as we go, put your questions in the Q&A box if you like. So thank you so much, Emmett. And I'm now delighted to give the floor to Professor Fan. Fan is a professor of metallurgy, the founder and director of BCAST at Brunel University of London. He is the principal investigator and director of the EPSRC-funded Lime Research Hub, a national center of excellence in liquid metal engineering. He is also the principal investigator for the UQRI Interdisciplinary Circular Economy Center for Circular Metals. Fan is going to present on full metal circulation to underpin a sustainable future. You have 15 minutes, Fan. I'll appear on screen when you have 3 minutes left. Thank you.
Can you see my slide now? I have shared. Diana, is that okay? Okay, good. Hello, everybody. It's different time zones, and as Diana said, my name is Fan. Just call me Fan. It's easier. And today, I would like to share some of our research work and ideas with you to see how we can reduce demand of metals. And Amit has gave me a very good presentation working on small metal like lithium. And about what I'm talking here is big metals and steel, aluminum, and all this large amount. And in particular, I'm going to focus on aluminum. So I choose the title Full Metal Circularity to Underpin a Sustainable Future. And I want to emphasize the sustainability problem has to be addressed from a systematic way, and which cannot be very localized, regional consideration. All this has to be from a holistic point of view. So that's why I choose this title here. But the purpose of this presentation, I want to demonstrate we can achieve sustainability without lowering our lifestyle or demand, but we can reduce the demand of metals, but satisfy all the engineering requirements. And I'll start with this car. We see in the year 2023, there was 1.65 billion cars on the road, the whole world. And each car on average is 1.9 tons. And 75% of the 1.9 ton are metals. So cars are millimeter from metals, and it's account for 3/4 of the weight. So to make all these cars on our road, and which requires 2.3 billion tons of metals. So that means 2.3 billion tons of metals have gone into all the cars which are running around the whole world currently. In terms of environmental concerns, there's two major things we need to consider. One is embodied energy, okay? Producing metals, which cause lots of energy and release of CO2. And every time you use metal, and the metal basically carries the CO2 with itself into your engineering design, to your product. So for cars, the 23 billion tons, sorry, 2.3 billion tons metals being utilized, which does say 23 billion tons of CO2 embodied into your cars before you use any, before the car emits any CO2s. And of course, and once you use the car, with the cars running on the road, and it generates CO2. So each year, about 7.9 billion tons CO2 emitted by all the cars. So you can see that's a big problem with this. And how can we reduce CO2, reduce energy usage? And we need to be very careful with this. And say, okay, we only electrify our passenger cars, of course, which will reduce CO2 emission significantly. But there's something very difficult to eliminate is the embodied energy, which is a large amount and which is always there. 10 or so years, we have proposed a solution to this problem. Is we call this the full metal circulation, and in scientific terms, which means all the engineering demand in the future can only be met by secondary metals, not primary metals. And I think you're using UNECE terms called virgin metals, and sometimes in literature we call it primary metals. So full metal circulation, which is simple terms, we don't do any mining at all. We only use what we already extracted, okay? Extracted as metals. We only use the secondary metals. And quite often a question people ask me is, that sounds good, but do we have enough to support your circulation? And today I'll demonstrate, and through different approaches we not only can meet the demand, have enough to circulate, we have more than enough to circulate. So the general approach to deliver full metal circulation, and we have three different approaches which accounts for the system approach. And the first one is narrowing the loop. And the metal circulating a loop, and then we narrow the loop. Narrowing the loop means use less. And how can we use less? As a general principle, we need to use less. And I will demonstrate how can we use much less here. And the other one is slow down the loop. Slow down the loop simply is any metallic products. If you can keep the product in circulation for much longer time, which will slow down the metal circulation, okay? Of course, the final one is closing loop, which all the end of products, metallic components, and all this has to go back to manufacturing for new products, and we close loop. So by the next few slides, I'll demonstrate each of these approaches, narrowing, slowing, and closing loop. And the first thing we see, slowing down the loop. Okay, I'll demonstrate. Slow down, as I said earlier, is you use much longer. Anything you have, use much, much longer, but we, of course, without reducing safety demand, without reducing the comfort, without reducing any human being desire, but using science technology, we need to basically use much longer. So we come up with the idea, which is called Mental Health Service, which is inspired by the UK's National Health Service. And National Health Service is very famous, very, very admirable, because in the UK, in theory, anybody, it doesn't matter you're rich, poor, you're old or young, you're entitled to have a full mental health service. And you have problem, you can go to the hospital, get it sorted, okay? So in theory, everybody being looked after. In reality, it's different, but it's at least the design is the same. So inspired by that, we call it mental health service. And this idea comes from a very simple fact. And you may not believe it. Metals and human beings and the metallic components are like and us, and we are very different. Okay, we have lots of feelings and all this. Metals doesn't, but in reality, metal and human being, they both can get tired after prolonged service or working. And the scientific research indicates something called fatigue, okay, and which is a very large subject in scientific research. And after usage, repeated usage of metal, and metal got tired. When these are tired, if you examine the metallic materials, and inside something called defects called dislocations. There's lots of dislocation built up inside. And we human being, if we use our arms to do physical work or even play sports, and the arm getting, after a long time, the arm getting a bit stiff. And the metal is the same. Once you have all these dislocations inside the metal, they get harder, and our muscles get stiff, which is harder. And if you don't stop, don't have rest, if you continue to work, and then we get sick. And the metal is sick, it's the same. And inside the metal got very tiny bands of irregular atoms, okay, which are arranged slightly different from the rest. And in human being, we may have further problem. We have our muscles changed in a different way, not only getting harder. And of course, we need to see the doctors now. And even after that, the metals, after a very long period of time working, the metals got small cracks inside, and we get tears of muscles, bones, and all this similar. So human being and metal have at least one thing in common: fatigued. If we use National Health Service to look after human being, using the same way to look after metals, and then we will have metals have a much, much longer service life. That's the idea of mental health service. And you can see I'm showing here on my left-hand side on the screen, you have the fatigue curve, which is sort of like a stress streak curve for fatigue. And you got different regions, which got the first region A, B, C, D, which corresponds to tired, sick, and broken, each human terms. And then we have developed a technique or mental health service in general. We need to develop techniques for diagnosing how tired, how sick metals are. And the other ones, we need to develop technologies to cure these problems. So on my right-hand side on the screen, and what you see is electrical resistivity measurements. And you can see the shape is similar, which means electrical resistivity can be utilized as an indicator how tired metal is, how sick metal is, okay? And next slide, we'll see we are developing technology for rejuvenating. Rejuvenating in human health service terms, which like a daily recovery. You have food, drink, and sleep. You recover very regularly. And we utilizing a demonstrator which is called electrical pulse. Apply a very fast, the pulse only lasts a fraction of a second, but with high energy goes in, and then you can see after every 200 cycles or so, you do a rejuvenating pulse treatment. And then you can see electrical resistivity is reduced very significantly. And then you can use again, and then you can rejuvenate. You can see the resistivity can be kept all low. That means the lower black dots, and the red dots is after you get tired. And the second one is called recovery. After some stage, you got a sleep band in fatigue terms, and this can also be reduced by electrical treatments, okay? And which, if you use one pulse, it can reduce the sleep band from original 55 to about 30%. And then you can use two pulses, which can reduce around 10%. You can see significantly you can recover sick metals. And on the far right-hand side here, as I'm saying, if metals got broken, got cracks inside, I'm showing you here is a very large crack in metals, which is about 60 or so micron. This can be also healed by electrical pulse, which like hospital for human beings, same, okay? So that's slowing down the loop. Closing the loop, which we see the simple terms about, we see recycle. Anything cannot be utilized anymore or out of service. You need to go back to manufacturing to produce new components, a new device. But the current problem with recycling, for example, with aluminum, as example, okay, all the problem for recycling is caused by human being. Because, for example, the passenger cars, end of life, and going to a scrap yards, they take out all the liquid and the non-metals, and all the metals packed into a small piece, and then put it into a big machine, like a big drawer, gobble it into very small pieces, about 5 mm sized pieces, and then separate steel and others, and then you leave aluminum. So this process made metals very contaminated, and it's human-made problem mostly. So with this, the immediate challenge with recycling of aluminum is about how can you get rid of these impurities and inclusions which causing quality problem for manufacturing. And in longer term, if you never mix different metals through design, through the engineering processing, and you still accumulate a bit of impurity. And then you need to develop a process which can cope with all this, okay, live with it rather than get rid of it. And in the first long, we see it's 30 years time through all the engineering developments and circular economy advancing and all this. We have metals come back as pure as original. So there's no such problem there. So this is about developing alloy which can be repeatedly utilized without any chemical and mechanical processing, okay? So that's the third long-term challenge. It's about alloy developing resilient alloys. So based on this, I understand at Brunel University, we have been working on the first two problems. And the first one, get rid of the excessive impurities and the inclusions, and in aluminum, which impurity major one is iron. Too much iron in aluminum, which causing big quality problem. So we need to get rid of this. We develop process. In one go, we can get rid of impurities, we can get rid of inclusions, and leaving the rest of the liquid metal in high quality, with very little impurity and with only very limited amount of inclusions. This, where I said we can live with it. So this technology has been proven in laboratory, and companies start to consider to utilize this. But as I said, this is a short-term problem. In the next 5 to 10 years, this might be okay. But 10 years later, recycled aluminum, there's no such amount of impurities. So this process will be redundant. Okay. So next one, we see, okay, how can we live with limited amount of impurities you cannot get rid of easily, okay? And you can always use a very expensive chemical process to eliminate any elements from metals, okay? But that's not economical and even causing more energy, releasing more CO2, okay? So what we're saying is that utilizing new science technology, we can live with limited amount of impurities and inclusions. And this is historification terms, and all the metals made of small pieces of crystals, which is normally about, we see a quarter of a millimeter size, which is very, very small. And each of them, they look like in normal case, look like a rosettes, the flowers, okay? The flowers actually is no good. It looks beautiful, but it's no good. The blue part with this diagram is the impurity, for example, iron. They are large, they are needle-shaped or plates, which is not very bad. So we develop the scientific process and technology to disperse this into very fine particles and disperse inside this so-called dendrites, which look at trees, okay, which is still a single crystal, but you can disperse this into very small ones. Now, those impurities, they are not only harmless, they can be also useful for straightening the metal. So this technology has been elaborate research and making good progress. So in a few years' time, this might be implementing in the industry. So in terms of the outcome, we have demonstrated that if you use this process, the fatigue life, in this particular case for the aluminum called aluminum-24 alloy, which is utilized mainly for automotive, and the life can be extended by a factor of 10. You use 10 times longer. And the second diagram showing, the bar diagram showing magnesium case. If you use this technology, 100% recycled alloy, the mechanical performance matching the virgin metals, okay? It's as good as that. So that's about closing. And finally, I'm talking about narrowing the loop, use less. And Amit has talking about lithium, how can we use much less to meet the engineering demand. But here with aluminum and steel, with large metals, the way here is not technology. Actually, we found out the most significant one is to utilize business models. So in the last 5-6 years, we have a national program called Circular Metals. And with this Circular Metal program, we have a team working on developing business models. And the outcome was published in this particular document called 2050 Circular Metal Vision, okay? Which is available in the internet. You just put this title in, you can search for the outcome. It's more like a small booklet. But here, what I'm saying is just see, okay, you just imagine simple terms. In 20 years' time, if all the car is owned by car producers, OEMs, and we don't own car anymore, so they own the car. We only use the service. Every time we need a car, we just text them. And within 30 seconds, you got a car at your front door to go to work, to go anywhere you want. We finish your business somewhere, just text. And then 30 seconds, there's car waiting at the place you demand to take you to the right place. And of course, there's no one driving the car. With that picture in mind, you can see how much metal we need, okay? And as I tell you, if you do it properly, this will reduce the demand for metals to 1% of the current level. If people argue, that's not 1%, that's 5%, that's the difference, okay? Reduce significant amount. So you can reduce the demand of metals through business. Science technology always critical and is needed, but only science technology will not deliver net zero. You need business to come in as well. So that's what I'm talking about, business model, and there's more detail you can read later on if you go to the internet, search for 2050 Circular Metal Vision, okay? And finally, I sum up to see we have proposed a new solution to the future metals, which we call full metal circulation, which can be delivered through narrowing the loop, slowing the loop, and closing the loop. And this will provide a very critical foundation for future sustainability. Thank you very much.
Thank you very much, Professor Fan, for putting all these technical matters in a language that's accessible to this interdisciplinary audience. I really like this language of curing and rejuvenating the metals. Thank you so much for that. We are also privileged to have a practitioner from the city of Oslo joining us today to offer some commentary based on her experience in Oslo. So I would like to welcome Ms. Kjersti Kofod to the stage. So Kjersti, you can start sharing your slides while I finish introducing you. And in the meantime, I also want to remind everybody that if you have any questions about Emmet or Fan's really interesting presentations, you can put them in the Q&A box, and Rauno is going to facilitate that after Kjersti's presentation. So Kjersti works in the city of Oslo's Agency for Improvement and Development as a senior sustainability advisor. She is responsible for following up on human rights due diligence requirements in the citywide framework agreements. Kjersti has more than 20 years of experience working with international development in various sectors and countries, and has previously worked both in local civil society organizations, international NGOs, and the Norwegian Agency for Development Cooperation. She has a strong background in human rights with a particular focus on children's rights. Kjersti, when you're ready, you have 5 minutes. I will just let you go through the time yourself.
Wow, it's always the same thing with the muting. Sorry about that. Hi, everyone. My name is Kjersti Koffel, and as Diana kindly introduced me, I'm a senior sustainability advisor, and I work specifically on public procurement and human rights due diligence requirements that we set in our contracts. So I've been asked to briefly comment on Mr. Emmett Hopkins' presentation and their report, and to exemplify how a city can go about reducing the need for private vehicles by showcasing some of the work that the City of Oslo has been doing. So I wanted to first bring up some of the policies and strategies we have in the city, because these are our steering documents. The climate strategy sets a target that we aim to reduce our direct emissions with 95% by 2030. And there's generally a strong cross-political support to this. And then the climate budget sets forth the concrete actions and measures to achieve the goals and targets in the climate strategy. And we've had such climate budget since 2017. It's important to note that the rationale for moving from private car dependency is primarily linked to the need for reducing CO2 emissions, and it's not a rights-based argument as such. However, there is, of course, a link and something which is coming higher up on the agenda. This is a chart that shows how our emissions are distributed across different sectors in the city. And as in the report, which was just presented, we see that emissions from traffic constitute the majority of the city's direct emissions. I'll focus on which practical steps the city has taken to reduce emissions coming from traffic and private vehicles. So there are three main initiatives on mobility and goals, really. That first of all, that all passenger cars on Oslo's roads shall be emission-free by 2030. And public transport shall be emission-free by 2028 at the latest. Then secondly, walking, cycling, and public transport shall be the first choices for travel in Oslo. Car traffic in Oslo shall be reduced by a third by 2030 compared to 2015. And then all light-duty vehicles shall be emission-free. All heavy-duty transport in Oslo shall be emission-free or use sustainable renewable fuels by 2030. So these are some of the activities and things we've done to reach these goals. First of all, it's important to note that walking, cycling, and public transport are key factors in reaching our goals. And as mentioned, these are a few examples of how we reduce car dependency. So more than 9,000 parking lots have been removed since 2015. The removal of parking lots is in practice a redistribution of street space. Parking is being turned into cycle paths, sidewalks, rain beds, outdoor seating, and playgrounds. We have prioritized bike lanes, giving space to bikes by removing parking lots and changing the setup of streets. Noise is, of course, a big problem in modern cities, and it's the same thing in Oslo, but we do have taken some action to reduce it. Electric cars are, of course, an important part of the solution, but it's also about lowering speed limits. By lowering speed limits throughout the city, we have managed to reduce noise considerably, and that creates a quieter, safer environment for our residents. And 70% of all municipal roads in Oslo are now 30 km/h. And then finally, it's worth mentioning the use of congestion charge and toll roads. This is definitely one of the city's most important climate measures. It provides emission cuts, traffic reduction, and traffic restructuring. And more than 95% of revenues from these congestion charges are earmarked for walking, cycling, and public transport. So, do all these actions and measures, do they work? And do they actually result in less use of private car? Well, one of the most important goals we do have achieved is zero growth in car traffic. And this is not a result of a single action, but as pointed out, it's really a combination of incentives and restrictions. It's about carrots and sticks. We've seen how tolls have acted as a stick to keep traffic growth in check, but the facilitation of public transport, cycling and walking has been even more important. When we make alternatives to the car more attractive, the car's competitive advantage decreases. And this has contributed to reducing traffic in the city and improving air quality. And this is not only a success for the climate, but also for the city's residents who can now enjoy a more accessible and sustainable city. So the numbers you see here, it's the numbers from 2024. So we've seen that in 2020, 34% of Oslo residents' trips were made in the private car, while 5 years later, their proportion has decreased to 24%. So 3 out of 4 travels in Oslo are now by walking, cycling, and public transport. I've not touched upon how our public procurement is being used as a strategic tool to contribute to this, but it should also be noted that the city has strict requirements to zero emission transportation of goods and services, and we are currently piloting a project investigating how the city itself can set up a car sharing pool for the light vehicles we use across different entities in the city. I wanted to finalize showing a photo, as images often tell a story better than words. This is a photo of the harbor area in the central part of Oslo in 1992. And this is the same area seen from the waterfront towards the land today. So it's definitely possible to create change. Thank you so much.
Wonderful. Thank you so much, Kirsty. It was really lovely to see the photos as well. And I'm sure others will have questions, but I am very interested in continuing to learn about the Oslo experience. Oslo is one of the cities where I'm interviewing practitioners for the project. A few words to close the seminar, and then I'll say a few words myself. Over to you, Nadishta.
Thank you, Diana, and thank you very much to all speakers. I think we had a really interesting set of presentations, but also interventions. I personally was very impressed, and also one more time to prove to myself how complex is the issue, how interconnected aspects we do have in this. So when we're talking about electric mobility, then we have to think not only about technological aspects, we have to look into different demand side measures. We have to always think about transformational strategies, policies at national level, but also at the city level. So this we have to think about the implementation of those policies, so the regulation and practical projects aspects. We heard also of several projects and researches also, and I mentioned also some of the frameworks that all of this come together. For me, it shows personally, and also at UNECE, we also think that this is a very good momentum, and to share different experiences that are happening, to create opportunity to discuss more about all these issues, because we're seeing that there is a lot of progress happening, but there are also a lot of questions, there are a lot of aspects that need to be sort of exchange, but also when we are exchanging our opinions, we also see how to improve the things. So how to work together, how to build on what experience showing us, being it some positive aspects, but being sometimes the lessons learned which need to be corrected also in a way. So that's why one of these ways I see that through such conversations like we had today, that shows already what is happening, and the experience and the all achievements of, for example, at the level of the Oslo, and we know that Norway is a pioneer in electric mobility, and there are also other countries that are moving forward in this. We know that a lot is happening also in the United Kingdom, in many countries. I won't be able to actually list things we are trying to understand. At UNECE, we're trying to collect all those actually practices and examples of what is happening, how to look on this not only from one angle, but from several angles. And today we touched one of the most important angles on how to look from a perspective of sustainable resource management to this aspect. So I would like one more time to thank all of you, the colleagues from the University of East England. Thank you, Diana, and thank you, Professor Uno, for co-hosting, for many organizational aspects that you had to cover from your side. I would like to thank you, colleagues from the Climate and Community Institute, Emmett, also Professor Fan from Brunel University of London, and Kirsty from the City of Oslo. I would like also to thank all participants, and I've seen that there is a lot of activity happening, questions which are raising interest in this. So I would like to thank all of you for this, and I look forward to have further discussions ahead. This is not the end. We from UNECE also will continue host events of similar way. We hope to have collaboration with all of you at the next occasions. So that's why I'm not saying goodbye on this. I'm saying let's continue this. Thank you.
Excellent. Thank you, Nadezhda. And I want to, I completely agree with Nadezhda on, gratitude for everybody involved in the webinar and the people who made it happen at such an awkward hour. Emmett, thank you again. So thank you to each of our speakers and Raul for his facilitation and the collaboration of the UNECE. There was a lot of enthusiasm and we had more participants than I expected. So I appreciate that all the people joined from different time zones, from many places. And we look forward to just continuing this conversation with you. It was, as you can see today, we can have very different types of experts and practitioners talking to one part of the topic. So we definitely have room to have more conversations and to hear from there's a lot of experts in the audience that we had a webinar format, so it's a little bit more difficult to have a chat, but there's a lot of expertise also among the participants, so it would be great to continue to be connected. Clearly the conversation, is not over, but we can see from this research that we had today and the experience of Oslo that in urban centers there are clear opportunities to address this issue of our resource intensity. And there are plenty of initiatives already. They may not always be oriented towards resource intensity to begin with. They might be for more greenhouse emissions, but they also end up having a similar positive effect. And I think there's an opportunity there to communicate that as well, that measures to reduce car reliance can also help us have possibly less intensive lifestyles in big urban centers. And I really enjoyed this conversation because it helped us remember that the policymakers, the urban planners, the people in the communities, the industry, so many people have roles to play here. So it's really a good opportunity for dialogue and for technical collaboration. So for the participants and for everybody here to keep an eye on each other's work, I've put links in the chat for everyone. And since you registered, we'll keep you posted and share the video of today and updates on the events that we all want to organize in the future. Thank you, everybody, for your participation today.
Thank you. Bye-bye, colleagues.
Thank you.
Thank you. Bye-bye.
Thank you, Professor Fan.